Have you ever attended an air show near Whiteman Air Force Base in Missouri? If so, you might have been lucky enough to catch a glimpse of the B-2 Spirit stealth bomber, which is considered one of the most unique aircraft in the world. With its wings spanning 52 meters, the Spirit resembles a manta ray, and its cockpit has an organic shape reminiscent of a sci-fi spaceship from the 1950s. Despite its unusual appearance, no nation seems to want to engage in combat with this impressive aircraft. The B-2 bomber was designed with a distinctive appearance for a specific reason. Its creation was a response to the advanced air defense system of the Soviet Union during the Cold War, which included ground-based radars, surface-to-air missiles, and aerial interceptors and radar planes. What advantages does the B-2's unique design offer in terms of avoiding detection by radar? The Pentagon's objective was to create a stealth aircraft that had an incredibly small radar cross-section, rendering it nearly invisible when observed up close. Given the significant role radars played in modern air defense systems, this capability was deemed indispensable. The F-117 Nighthawk, the initial stealth aircraft of the Air Force, showed potential but had limitations. It could only carry 2 bombs for a distance of 900 miles without refueling, which was not enough for a strategic strike deep within enemy territory. Aviation engineers explored flying wing designs, like Nazi Germany's Hortenho 229 and the USX BG-35 and YB-49. These flying wings provided extra lift and, coincidentally, had low radar visibility due to their flat surfaces that minimized radar reflection. However, the lack of tail control surfaces in pure flying wings often led to fatal instability. The B-2's design aligned with a pivotal period in the implementation of fly-by-wire controls, which allow pilots to convey their instructions through an electronic interface rather than relying on hydraulics. This innovation permits a computer to compensate for any unstable flight characteristics. The fan blades of jet engines and the emission of hot engine exhaust make them a major weakness in stealth designs, as they are easily detected by radar and infrared sensors. To address this issue, the Spirit's intakes are located on the upper part of the wings, and air is channeled through S-shaped ducts to 4 F-118 turbofans that are deeply embedded within the aircraft. This distinctive setup significantly reduces the B-2's acoustic and infrared signature, thereby improving its stealth capabilities. In addition, the Spirit employs extra openings that collect extremely cold barrier air near the bomber and mix it with the hot exhaust. This combination is then released over a flattened surface composed of titanium carbon fiber, effectively scattering the heat signal. The B-2's ability to avoid detection is also due to the use of materials that absorb radar. The majority of the aircraft's exterior is made up of a non-conductive carbon graphite composite mixed with titanium. To further decrease its radar signature, the most reflective areas, such as the intakes, flaps, and leading edges of the wings, are coated with additional radar-absorbent materials that have undergone various modifications over time. Additionally, the exterior is coated with an elastomer, a flexible rubber-like polymer that smooths out any seams, screws, or joints between different materials that could potentially compromise its stealthy design. All of these features combined result in the B-2 having a radar cross-section of approximately 0.1 to 0.5 meters square. While it can reach a maximum speed of 630 miles per hour, slightly faster than a commercial airliner, the B-2 Spirit's greatest advantage lies in its ability to undergo 2 to 4 aerial refuelings through a pop-up hatch located behind the cockpit. This distinctive feature allows the aircraft to conduct continuous missions lasting up to 2 days, enabling it to strike targets anywhere on the planet. The Spirit's versatile team, which includes a mission commander and a pilot, enters the aircraft through a hatch located on the bottom. The bomber is equipped with amenities such as sleeping quarters for crew members to take turns resting, as well as a toilet and a microwave for storing food. Although Spirits usually rely on GPS navigation, they can still function efficiently even if the navigation satellites are disabled by utilizing a star-oriented inertial navigation system that is backed by a terrain recognition-based system. The crew can receive updates about the mission, including the cancellation of a planned target, through satellite links and very high-frequency radio communication. As the B-2 bomber approaches protected airspace, it smoothly shifts into stealth mode by retracting antennas, severing certain communication links, and restricting the use of flaps to avoid detection from long-range radars and missiles. Additionally, the bomber may descend to low altitudes and use its terrain-following system to fly as close as 200 feet above the ground, further reducing the risk of detection. The B-2 bomber has an advanced APQ-181 radar that is more stealthy than the previous Nighthawk radar. This radar is beneficial for various purposes such as navigation, scanning ground targets, and identifying enemy fighters and radars. The information gathered is utilized by the bomber's PR-63 defensive measure suite, enabling the mission commander to modify the predetermined flight path to evade interceptors and maneuver through areas with intense radar coverage. While low-bandwidth radars may detect the existence of stealth aircraft, they are unable to accurately pinpoint their exact location. If an enemy fighter approached within a few dozen miles, the Spirit would be easily detectable through visual, infrared, and radar methods due to its lack of self-defense weapons or high-speed capability. As a result, the B-2's chances of survival in such a situation would be greatly diminished. The B-2, which continues to play a crucial role in its nuclear strike mission, has the capability to transport a maximum of 16 B-61 or megaton-yielded B-83 nuclear gravity bombs in its 2 bomb bays equipped with rotary launchers. To ensure protection against the electromagnetic pulses produced by nuclear explosions, the avionics of the Spirit aircraft are reinforced. Additionally, the pilots are provided with eerie white face masks to safeguard their eyes from the intense flash of detonation. However, due to the collapse of the Soviet Union, the Air Force was forced to quickly adapt the B-2 for conventional weapons use. They introduced a new rack system that could accommodate up to 80 Mark 82 500-pound bombs, or an equivalent weight of cluster bombs, mines, or larger munitions. Later on, in the late 1990s, additional modifications were made to the B-2, allowing it to carry 2,000-pound JD AMGP's guided weapons. These weapons are highly accurate, with a precision of within a 20-foot radius, and have remained the primary armament of the B-2 ever since. The B-2 has the ability to transport a GM-154JSOW glide bombs that have an extended range of 80 miles and a GM-158J ASSM stealth cruise missiles that can travel between 230 and 575 miles. This feature enables the aircraft to execute standoff attacks, minimizing the likelihood of encountering advanced air defense radars. The B-2 is uniquely built to transport up to 2 enormous 30,000-pound GBU-57 massive ordnance penetrators, which are specially designed to destroy command bunkers situated as deep as 61 meters below the surface. This extraordinary feature aims to intimidate hostile foreign leaders by directly targeting their command centers and obliterating underground weapons facilities. The B-2 is an extremely specialized military vehicle that has the ability to transport powerful weapons into heavily guarded airspace. Its exceptional features make it an invaluable asset, surpassing all other aircraft except for China's potential future development, the H-20 stealth bomber. While the B-2 has mainly relied on its range and payload in combat situations, its ability to remain undetected and its impressive firepower have not yet been put to the test in a high-stakes conflict, potentially involving nuclear weapons. This poses a new obstacle for the B-2 and its capabilities.